Right, welcome back. We are now going to look at the detailed UPAC rules for naming hydrocarbons. What does the prefix UPAC stand for? It stands for International Union for Pure and Applied Chemistry. What it simply means is this is the group of people within an organization, which we call a body, that actually decides on important issues that are related to chemistry, and they have to come up with universal rules and laws that have got to be followed by all chemistry people in the world. So because you're studying chemistry, whatever you do is going to be determined by these people. For example, right now, when it comes to naming compounds like these hydrocarbons, they set the rules. So what are the rules then? Rule number 1 is choose the correct ending for the hydrocarbon you are naming, either "ane" or "in". Okay, because these are the ones we're dealing with at the moment. We know that if I give you a formula such as C4H10, you can, because we have looked at this in a previous video, this one satisfies the general formula H2N plus 2, which means this one is an alkane. For naming this, I'll just name this as butane, because I don't need to worry about side chain, because I don't know if there are side chains in that molecule or not. It's possible for me to represent this C4H10 differently. Like I can have it like this here, and then I can have the hydrogen atoms around it like that, and I've got hydrogen and CH3 like that, right? So what happens then is this one here is still CH410, but it has got a different name because the longest chain is not, it cannot be butane because my longest chain is a 3 carbon chain. So this one will be propane. So the name for this one is methyl propane. But if I write the formula, it's C4H10, right? These here, this compound and that compound is what we call isomers, which we're going to study later. So if you're given a molecular formula like this one here, the one we have above there, it's really hard to give a detailed name of the compound, which can be useful to anyone who wants to actually reproduce that compound as it is. Why is it important to be able to reproduce the compound as it is? For example, if I give you a compound like this one here, right? I'll remain with the butane, which is this one here. If it's butane like that, and I change it to methyl butane, right? What it means is they are completely different substances. Methyl propane, right? Methyl propane, which we saw earlier, which I wrote down earlier, which looks something like this with a methyl group on the 3rd carbon like that, and this one, they've got completely different chemical and physical properties. Also, in as much as, let's say there was a chlorine here, if I don't tell anyone where the chlorine is on this 4-chain carbon chain molecule of butane, they're going to be confused because they'll say, is it on carbon 1 or carbon number 2? Because moving this chlorine to carbon number 1 will change the chemical properties. I'm not worried about moving it in this direction because this is a symmetrical hydrocarbon. So if I move this chlorine here, it's just the same as I've put it here, because I'll have to start counting from this end. It will still be number 2. So it's important to do that. So first of all, we need to figure out the "in" or "ane". On a displayed formula, the "ane" has got no double bonds at all. The "in" will have at least one double bond, and we know we're dealing with only one double bond for the molecules that we are working on now. And once you've done that, like this here, if I look at this displayed formula, I've got all single bonds in this one. So this one ends in ANE, this one ends in ENE, because I've got this double bond here. Now, where do I go from there? I've figured out the ending, which is the suffix. Next up is we need to determine the longest chain of carbon, continuous chain of carbon atoms in the molecule. We've already done this one. We figured out the longest chain is this one, and I also reiterated that the longest chain does not need to be the straight chain. It can be windy, as we saw with that tree, that we can have the stem going the other way. It's a possibility. The rule is, what's the longest continuous chain, right? Where there's a double or triple bond, which we don't deal with triple bonds at this stage, but I'm just extending you. It doesn't do you harm knowing that if there's a multiple bond in the chain, the multiple bond must include the chain, must be included in the chain. I remember giving an example like this one here, where I did say, if you have got 1, 2, 3, and you've got a double bond here, and this one branches right there, and it goes like that, okay, and it comes down here, it goes like this here. It can go whichever way it wants, right? We can't control that. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the longest continuous chain for this one here. But this longest continuous chain does not include the double bond. That's what we mean. So my longest chain is not going to be this one. It's going to be it's not going to be the first one that I've identified, which is this one with 10 carbon atoms. My longest chain is going to be this one instead, which has got how many carbon atoms? 1, 2, 3, 4, 5, 6, 7. So this one here will be hept. That's it. And the ending is in, right? So it will be a heptene, but no, we haven't finished naming it yet. There's a lot more we need to do. If there's a cyclic structure present, the longest chain starts and stops with the cyclic structure. I'm going to do these cyclic hydrocarbons separately, but let's say I've got a carbon there, a carbon there, a carbon there, and I wrote this one like that, and there is a CH3. My longest chain is just this circle here. The number of carbons in the circle will be my longest chain. For the course we are doing, we will never come across the scenario I'm going to give you now. It's a possibility that I can have something like this with a longest chain that has got more carbons than what's in the ring here. This will be our principal chain. That will be our side chain. So when the side chain on a cyclic hydrocarbon is longer than the ring that you have, then it becomes your principal group. This one becomes the side chain. But look, stress ye not, I'm not going to actually go through this because it's not part of your syllabus. I just mentioned those things so that you know it doesn't do you any harm to know about that. So let's move on. Okay, so that's how we determine the longest chain for alkanes and alkenes. Now, depending if there is a cyclic structure as well, we need to attach the prefix cyclo. Like if we look at this one here, it says attach that a prefix that corresponds to the number of carbons in the parent chain. Add cyclo to the prefix if there's a cyclic structure. So what am I doing here? What I'll do is, if I count that here, I know that this is decene, which is D-E-C-E-N-E, decene, right? And this one is decane. That's the principal name. We're still working out the principal name, guys. We're going to bring in all the things, and then, you know, these are going to change as we go, because we have to, like this one, we have to state the position of the double bond. Now, this is what we mean by attach the prefix that corresponds to the number of carbons. This one has got 10 carbons, so the prefix is dec. Now, we know that our principal name is going to be something decane, and another one for this one is going to be decene. Now, if it's a cyclic structure, we add the word cyclo. So if it was cyclic with 3 carbons like that, this one would be cyclopropane or cyclopropene. If there was a double bond, right, we add the prefix cyclo. We're going to do cyclo and cyclic hydrocarbons separately. This is just to show you that the rules are the same, but you know, we just tweak them slightly, change them slightly to suit cyclic hydrocarbons. Now, let's move on to the next one. The next one says, assign numbers to each carbon of the parent chains. For alkenes, the first carbon of the multiple bond should have the smallest number. So what we're looking at is I'm interested in the last part here because we've been looking at this in the other video. I'll re-mention that, but I'm just looking at the last part. If I'm numbering this one, because my chain starts here and the double bond is closer to this carbon, that will give this double bond the lowest possible location number or locate number or position in the chain. So the multiple bond must always have the lowest possible location number. If I count from here, that will give the double bond the largest number, the location number. But even if we were to look at it this way, from the double bond, if we were to say, okay, this is where it splits, we find it's heavily substituted on this side, but it doesn't matter. What takes priority is the double bond. Okay, so here we are not worried about double bonds. Instead, we are looking at the side chains. The side chains, the total sum of the location numbers for the side chains must be the lowest possible sum. So side chains matter for this one. We've looked at that in the other video. That's why we're numbering it from this side instead of that side. Okay, let's move on. The next rule is carbon in a multiple bond must be numbered consecutively. So this carbon and that carbon, we number, this must be 3, sorry, this must be 4, not 3, this must be 4, this must be 5. This doesn't have so much of a bearing when you're looking at a straight chain, because you can only, you'll have to jump, you have to number them consecutively. It only has and presents an issue if the double bond is on a cyclic alkane, like this one here. So I've got carbon, carbon, carbon on each part here. So if I was counting, yes, this is my, if I choose this to be my carbon 1, I can't count going that way because this carbon and that carbon, the carbon that contain the double bond must be numbered consecutively. So this will be my carbon number 1, carbon number 2, because if I go this way, this will be carbon number 1, that will be carbon number 6, which makes these two carbons that are sharing the double bond not to have consecutive numbering. So this one will be number 2. We can't go this way. It's not the correct way. The correct way is to go this way, right? Okay, now let's move on. For alkanes, the first branch or first point of difference should be, they have the lowest locant number, right? So if we look at it this way, when it's a straight chain, the first alkane, first branch must be, but it all depends, because what you have to consider is, if I look at this one, I've got 1, 2, 3, 4, and here I've got 1, 2, 3, 4. These two are first points of difference. In that case, this one here is heavily substituted with similar groups. This one, even though it's heavily substituted, but they're different groups, right? Which I have to consider now, which one would give me, which way would give me the lowest possible combination of locant numbers. I think that's the easiest way to look at this. With this rule here, I wouldn't want you to be picky about that. Just follow what I've told you. Aim to get the lowest possible sum for all the positions of the side chains in an alkane. In an alkene, the lowest location number must be for the double bond. That's all you have to focus on. So now, determine the correct name for each branch. We have looked at how to name the branches. We've got 3 branches that we're supposed to know how to name. The alkyl groups. We have got the halo alkanes, which is the halogen groups, and I've given you another extra one, which is the nitro group, which is the NO2. We know how to name the alkyl groups. If you don't know how to name this, go back to the other video. I'm not going to go over it again on this one because we don't have the time for that. It's already covered elsewhere. Now, so we determine the name for each branch, right? Like here we determined that this was a methyl group, this was a methyl group, this was a ethyl group, this was a methyl group, this one was a propyl, and then we've got an ethyl group there, which is what we did last time, naming this one here. Once we have done that, we need to put everything together now. We have to attach the name of the branches alphabetically along with the carbon position to the front of the parent name, right? So what we need to do, like what we did here earlier, to say this was 4, this was carbon number 5, this was carbon number 6, 7, right? These are our side chains. So we ended up with 4, 4, 7. This is what they mean for methyl, and then we ended up with 7, 5 for ethyl, and on and on. So we are attaching these. So when we put them in alphabetical order, what it means, ethyl would come first before methyl, and methyl will come before propyl. If we've got these prefixes, this is gonna end up with trimethyl, right? And this one, methyl, this one is going to end up with trimethyl, and this one here is going to end up with dipropyl. Let's look at it this way. Or propyl. Dipropyl or dipropyl, it depends how you want to pronounce that. Now, because this one is starting with D, that's starting with T, it doesn't mean that propyl will come before methyl. These prefixes here that we use to denote the number of side chains that there are, it doesn't count when it comes to putting these in alphabetical order. So we have to actually be aware of that. So we have named this already. I'm not going to go through the process of naming it. It has been named in the previous video. I'm just using this again so that you can see how we ended up with that long name. Now, let's look at the next one. Prefixes are ignored when determining the alphabetical order. That's what I said earlier. And another thing here, which was on the which is not here before we go on to prefixes, when you are looking at an alkene, right, we need to state the position of the double bond on the principal name. So this one becomes dec, and then 1, 2, 3, 4. So the first carbon we arrive to is carbon number 4. So it's 4-dec in. This is the name for this one here, 4-dec in. I'm going to name this one actually because we didn't name it. So let me clear this and make room for me to name this one. This one has already been named in the other video. So we say this one is dec 4 in. Okay, so it means it's 10 carbons. On the 4th carbon, there's a double bond. That's what it means, basically. Now, and we look at the side chains. We've got a methyl group here. On 4, we've got a methyl here. And we've got an ethyl group here. And we've got 2 propyl groups. Right? So the positions for this one, it's 4, 5, 6, 7. So this one will still remain 4, 7 dash dimethyl, and this one will be 7 ethyl, because we've got 1 ethyl now, and this one will be 5, 6 dipropyl. Now, with this one, we don't have to worry about adding up these here because it doesn't matter. As long our double bond has got the lowest locant number, that's fine. So when we put this together, right, what we're saying is we've got 7 ethyl, dash here, dash 4, 7 dimethyl, 4, 7 dash dimethyl, dash, sorry, not, yeah, dash, we still have to do 5, 6 dipropyl, dec 4 in. That's the correct name for that. So let's just go on, follow the rules and see where they take us. When 2 or more branches are identical, we use prefixes di, tri, tetra, di for 2, tri for 3, tetra for 4, and then from there we start from penta onwards, right? Penta, hexa, hepta. But really, like I said in the other video, once you start to get to the penta and hepta in terms of your side chains, there must be something wrong, okay, with your numbering, because it's really rare at this level. When identical groups are on the same carbon, repeat the number of this carbon in the name. For example, 2, 2. So I said in the earlier one we had 4, 4 here. That's what this rule is saying. We've got methyl groups sitting on the same carbon, so we repeat the number of the carbon. So that's why we ended up with this one as 4, 4. And then we numbered this one then as 7 trimethyl. Okay, so we have to repeat the numbers or when they are sitting on the same carbon. The next rule is separate the numbers from letters with hyphens, with a dash. This one is a hyphen. I call it a dash as well, but look, it's a hyphen. That's the correct way to name it in English. And numbers are separated with commas, like I was doing here, 7 dash ethyl dash 4,7 dash dimethyl dash 5,6 dash dipropyl dec 4 in. We have to separate those with hyphens. Okay, let's move on. I'm going to end this video here because we've done all the rules. The next part now, we're going to do a skill practice activity naming alkanes and alkenes before we move on to cycloalkanes and cycloalkenes. I shall see you when you watch the next video.